So the reason why we look at long division and synthetic division is because it can be another kind of like tool that we have when it comes to factoring and like breaking down, you know, a polynomial or even a quadratic. You know, well, that's including polynomials, but it's a tool that we can use to help us factor, right? Because we saw, you know, a couple strategies 2 days ago with, you know, like I want to say, you know, factoring using a GCF, factoring using like substitution, you know, where it looks like a quadratic, so we factor kind of like a quadratic kind of thing, and also where we use factoring by grouping, right? But I told you that those strategies, while they're helpful, right, there are still polynomials out there that do factor, but that don't follow, those strategies won't help us for it, right? And so we need some more tools potentially. And so long division and synthetic division are some really helpful tools. And again, once we get any polynomial down to a quadratic, then we're done, because we know that a quadratic, if it doesn't factor, we can at least use a quadratic formula to then get the rest of the roots and zeros and things, okay? But what if we can't get it down to the quadratic with any of the strategies we have? Well, like I said, long division, synthetic division can come into play here to help us out with that, okay? But before I show you that, let's review how to even do long division, because I know you children of the Common Core might not know this algorithm as you know, familiar as you know, other students in the past, because that's not what Common Core is about. But we're going to do it anyway.
I once knew how to do long division, but I forgot.
Yeah, that's why we're going to review it.
So long.
So let's review this algorithm that we have for dividing numbers, okay? So we want to take 1,793 and divide it by 4, okay? And so we'll take that 1,793, okay, and put it in our little box, or half box there, I guess, whatever you want to call it. Okay, we'll put our 4 right there in front because we're dividing by the 4. Okay. And the way we kind of do this algorithm, the way we kind of like work out our mathematics here, I guess, is we start, you know, with our furthest, I guess our highest valued place. So like in this case, it's the thousandth place, all right? And we kind of ask ourselves the question, okay, how many times does 4 go into 1? Or how, you know, how many times can we divide 1 by 4? And the answer is, well, none, right? It doesn't go into that, all right? So then we expand our look here, and we jump then to the hundreds place, but we still count that thousand. So we count it as 17 now, and we're like, all right, how many times does 4 divide 17? And the answer is, yeah, 4 evenly, right? The most we can do is 4. And so we'll put a 4 above that in the hundreds place as well, okay? And then we'll multiply. 4 times 4, we'll get 16 here, and we're going to subtract that from our original amount there, 1,793. Okay, we're really, I guess, subtracting 1,600 in a sense, but it doesn't matter too much that that's the case. We'll bring down the 9 here. Okay, we can see that we chose well. All right, we can see that we chose well because what we had left over, a 1, right? 4. There's 4. You can't take any more 4s out of a 1. 1's too small. But now we bring down the 9. Now we have a 19. And so, how many times does 4 go into 19? 4 times again, right? We're almost to that 20, but it's not quite, so we have to say 4 again. So we'll subtract 16 again, and that's a 3. Again, we can see that we chose well because that 4 and the 3, right? We can't divide that anymore. There's no more 4s there. And then we'll bring down the 3. And then how many times does 4 go into 33? 8. 8 times, right? So 8 times 4 will give us the 32 there. We'll subtract, and we're left with a 1. Okay? And now at this point in your, you know, kind of desire to answer things, we have kind of two different options we could go with. Option 1, we can come up with a remainder here. So what is the remainder of this problem? 1, right? And if we want to make it like a fraction, it's 1 over what? 4, right? Because this 1, right, of all the stuff that we've divided here so far, this 1 has not yet been divided by the 4. It's still remaining to be divided by the 4 there. So we'll just say, we could say 48 and 1/4.
Or 448.25.
Right. So alternatively here, and I'll put this in here. I'll put this in here. Alternatively here, if we did the whole thing over again, so please, just bear with me here as I rewrite this all over. Okay, just for those that are curious, because you can actually use this algorithm to figure out the decimal here, we would add on a 0.0 here, and you could drop down the 0, okay? And so you could say, how many times does 4 go into 10? The answer would be 2. And so we'll put a little decimal right there as well because we're starting our decimals. So 2 times 4 is 8. Minus 8 gives us a 2. I'll put one more 0 here. How many times does 4 go into 20? 5. And it's exactly, isn't it? And so I can subtract that 20. And voila, we've got our decimal too. Okay? So the algorithm works also if you're trying to find the actual decimals and stuff. You just add in a decimal point, start putting down zeros. Okay? And then, of course, if you've done that, sometimes you'll recognize, there are situations, right, where the decimal goes on forever. But hopefully you'll see, you should see a repetition at some point, kind of thing. Okay, you should see a repetition at some point. Okay, or it'll terminate. Okay, so that's division. So any questions on that? Okay, has anyone never seen long division before using that algorithm? Okay, I guess if you've been through Algebra 2, which you guys have done long division there, then at least that's that. But that's interesting. Were you guys taught this in elementary school?
I haven't used it since middle school.
Yeah, elementary school. First grade, you were, Ro? Yeah? Jenna? Yeah. Okay. Yeah. So that's what I'm saying. So you guys didn't learn this in elementary school? Some of you did? Right. Okay. Yeah.
I used it,
Yeah.
I learned it in late elementary school.
Okay.
And I used it all through middle school, but then I forgot in high school.
Yeah. Okay.
Elementary school, and then we were introduced to calculators.
Yeah, I gotcha. That's fair enough. I understand that. And that's, I was just watching, someone posted a picture last night of 90s teachers, and it was you're not going to have a calculator in your pocket all the time, and now, everyone does have a calculator in their pocket all the time, if you've got a phone at least. It's kind of well, I guess so. But, and again, it's nice to know this, at least I think, but what I did want to say is, I can remember I learned this, I think, in 4th grade, and I think I was absent the day that they taught it, the first day that they taught it, and I remember coming back the next day. I was sick or something. I came back and I was I felt so behind because it was so crazy weird or whatever, anything. So I get it. It's a weird algorithm in a sense, but it does work, okay? And there is some sense behind it, but if we never teach the sense behind it, we're just here, do this, and Mathemagic, it works. So, all right, anyway. So let's see then how we're going to now apply this to something like... something like, a more common kind of context. Now, there are many contexts in which you might have to use long division or synthetic division, okay? For our context, right, the idea is we're trying to use it to kind of, in this case, we're trying to just simplify this fraction, okay? But also, we can use it, like I said, to factor and stuff like that, too. Okay? So, this is division, right? When you have a big fraction bar like that, it means division. So we'll put that x minus 2, okay, on the side there, and we'll put the 6x cubed minus 19x squared plus 16x minus 4. Okay. Is it important that we have the polynomial in descending order here? Yes. Yes, very important. Okay, very important. Okay. So make sure you have your polynomial in descending order there. All right. So the process for the algorithm, right, is the same as what we did up here with the numbers. So again, if you remember, we started by taking our 4 here, and we looked at that 1, the very first term, and we were like, okay, can 4 divide into 1 evenly? The answer was no, right? And so we had to say, okay, does 4 divide into 17? Or what times 4 gives me 17? The closest we could get was the 16, right? We did 4 times 4, okay? And then we subtracted, we were left with the 1, brought down the 9, 19. What times 4 gives me 19? We did another 4. Just like that. So we'll do the same thing here, okay? So we're going to look at that first lead term here, and we have an x minus 2, and we're going to look at, since we have 2 terms, we're actually just going to use the lead term here to guide us. So we're just going to really consider the x, and then we won't worry, the 2 will be there, it'll be part of it, right? But we're just going to use the x to guide us for this problem. So same kind of question. What times x will give us 6x cubed? 6x squared, right? So we'll put a 6x squared right there. Okay, and I'll do 6x squared times x, 6x to the third. Okay, and then the 6x squared is also going to multiply to the minus 2, so minus 12x squared. Okay. And then we're going to subtract this quantity. But I don't really like subtracting, so I'm going to change all these to add the opposites. So plus a negative 6x cubed and a positive 12x squared. Okay? Because I think it's much easier to add than subtract. It's more thinking than I want to do. Right? So the 6x cubes cancel, and they should, right? But these might not cancel, and in fact they don't. So negative 19 plus 12, negative 7x squared. And then what? From here we do what? Bring down the plus 16x. Exactly right. We really only want to have 2 terms at a time right here because what we're dividing by only has 2 terms. Okay, so we don't need to bring down that minus 4. If we were dividing something with 3 terms, then we would bring down the minus 4 as well. Okay. All right, what times x gives us negative 7x squared? Yeah, negative 7x. So multiply negative 7x squared, and then positive 14x, and again subtract the quantity. But again, instead of subtracting, add the opposite. Okay, so negative 7's cancel. We're left with 2x. Bring down that final minus 4 there. Then we'll multiply by, so what times x gives us 2x? Well, 2, right? So 2x minus 4. So minus plus those cancel, and we have a remainder of 0.
What would you do with the remainder if you did have a remainder in this kind of problem?
Good question. We will look at that in a little bit. So hold that thought. Okay. And short story, Jeff, it's going to be very similar to what we did with the remainder in the earlier problem that we did.
So you're just going to tack it on at the end?
Mm-hmm. As a fraction.
Okay.
Yep. So now, with this successful division that we did and a remainder, okay, that we kind of got, okay. What can we say about x minus 2? Is x minus 2 a factor of 6x cubed minus 19x squared plus 16x minus 4?
It is.
It is. How do we know?
Because it divided even.
There's no remainder. It divides it evenly. Yes, yes. Both of those are good answers. Okay. Now, that's not what the question really asked, but I just want to make sure we have that connection there, right? If we divide, if a polynomial gets divided evenly by another polynomial, that means that thing we're dividing by is a factor. Okay. So now, I'm going to put the simplification here. So this top polynomial then is equal to x minus 2 times our answer here of 6x squared minus 7x plus 2, right? We can, since taking our original polynomial, 6x cubed, dividing by x minus 2 yields this, that means this factors to x minus 2 times 6x squared minus 7x plus 2 all over, then that x minus 2. And using what we have about fractions, what we know about fractions, right? What can we do with those x minus 2's? And they cancel, right? They simplify. So this cancels and this cancels. Okay? And so we're left with then 6x squared minus 7x plus 2. Okay? And these 3 things are equal everywhere except when x is what? If x is 0, it's okay. Not 0, at 2. Why 2? Yeah, so in the original function, 2, if you plug it in, you're going to get some number on top. Actually, you're going to get 0 on the top, but you also get 0 on the bottom, right? Okay, and 0 divided by 0, that's not undefined necessarily. It's indeterminate form, okay? And then we're saying, so here 2 gives us 0 over 0, but here 2, is 2 a problem in this? No, 2 we can plug in, no problem. So you can see the issue here, right? If we're trying to say that 2 things are equal, if 2 things are equal, they need to be exactly the same. Not the same everywhere but a single point. So oftentimes when you see a situation like this where you simplify something and you're saying two things are equal when they're not exactly equal, you'll see something like a comma and then like x not equal to 2. Okay? So we'll just stipulate that these things are equal everywhere except where x is equal to 2. All right? I'm not going to be like so harsh about that when it comes to like you guys doing your work, but I want you to understand that when you see that, that's the reason, okay? Don't ignore these, all right? I know sometimes we as math teachers, we ignore this stuff, and then you guys ignore it too because like, well, if they don't care, why should I care? But I think, it is important to ask, why is that there? What does it mean? Because, things are written for reasons, right? It's very rarely that you just see something that doesn't have any meaning behind it. Okay, so anyway, that's that. Okay, but the main goal, of course, is that we can get that simple division right. All right, let's keep going. All righty. So let's do one more here together, and I'll have you guys try one. Okay, and then we'll get into synthetic division. Okay, so simplify. Actually, let's just say this, not simplify. Let's just say divide. Sorry. All you pen writers, I know. I'm awful. Okay. So here's our division. All right, so x minus 3 goes outside our little box. All right, x to the 4th minus 10x squared. Oops, wait a minute. We're missing something here, aren't we? There's no x cubed. So should we just skip it, you think, or? We need a placeholder, that's right. Okay, so x minus, I'm just going to do it over here now. X minus 3, x to the 4th plus 0x cubed minus 10x squared minus 2x plus 4. Okay, yes. Super important that you put intermediate placeholders in, right? We don't need to put in 0x to the 5th, 0x to the 6th, 0x to the 7th. Those are, outside the scope of our problem. But that 0x to the 3rd, that's between that x to the 4th and negative 10x squared term. We need it in there, okay? We need it in there. And so now we've got it, all right? And it basically just helps with the algorithm and makes it, work a little bit nicer for us. Okay, so same question here. What times x gives us x to the 4th? X to the 3rd. And so x to the 3rd times x gives us x to the 4th minus 3x cubed. We'll subtract that quantity. Okay. But again, instead of subtracting, add the opposite. And so on and so forth there. Okay. You do want to be careful here because there's lots of like little calculations, little arithmetic, right? And if you make one mistake early on, you're guaranteed to get the rest of it wrong then, right? Because as soon as you make that one mistake, it just kind of cascades through the rest of the problem, and there's no, recovering from it unless you find your error. Okay. So let's see here. For 3x cubed, we'll do a 3x squared. And then minus 9x squared. And then subtracting, I'll add the opposite. So those cancel, and we get negative 1x squared. Question, yes?
Sorry, I understand that. Never mind.
Okay. No worries. All right. And then what times x gives us negative 1x squared? So negative 1x. And that's positive 3x minus the quantity. So add the opposite. And then minus 5. Am I going too fast?
Yes.
Okay. Sorry, I figured everyone else was just zipping ahead of me, so. Okay. Is it too small?
No, I just got lost.
Okay. So, okay, so let's see here. So let's see, negative 1x. So we had negative 1x squared minus 2x, right? We brought down that minus 2x, okay? So I'm looking for, what times x gives me negative 1x squared, right? So negative 1x times x gives me a negative 1x squared, right? So negative 1x squared, and then negative 1 times negative 3 is positive 3, so plus 3x. But then I was subtracting that quantity, so I made it plus the opposites. So instead of subtracting a negative 1, I added a positive 1. And instead of subtracting a positive 3, I just added a negative 3. Okay? And negative 2 plus negative 3 gives you negative 5, is where that 5 comes from. Where did 15 come from? Negative 5 times x, negative 5x, negative 5 times negative 3, positive 15. Okay, and then when you subtract the quantity, I instead made it add the opposites. Okay, so instead of minus a negative 5, I added the positive 5. Okay? So I guess the add the opposite thing, that's instead of subtracting quantity, you can add its opposite, right? So instead of subtracting a positive 5, you can add a negative 5, right?
I think it's just how you write it. I get confused.
Okay. Gotcha. So would you prefer that I didn't change the addition and just make it leave it subtraction?
No, if it works for everybody else, it's fine. I just have to learn to ignore it.
Okay, I got you. So you prefer to leave it as subtraction?
I just change it while I'm writing it.
I got you. Okay.
So I don't get confused with all the extra steps.
Gotcha. Or you take the extra steps intermediately. Okay, but we do get a remainder. Remainder is negative 11. Okay? So, what can we do with that? Similar to what we did with the other problem here. Okay? So that negative 11 has yet to be divided by the x minus 3. It still remains to be divided. So, we can put plus and then the remainder, negative 11, over x minus 3. Okay, just like that. And so that is the divided answer right there. Okay. Does x minus 3 evenly divide our polynomial x to the fourth minus 10x squared minus 2x plus 4? No, because why? There is a remainder of something that's not 0. Yeah, remainder is not 0. Okay, that's right. In this case, then, we can say, if we wanted to, x to the third plus 3x squared minus 1x minus 5 plus negative 11 over x minus 3. It's okay to say that these two things are equal. I don't even need that stipulation that x cannot be 3, because for both of these situations, 3 would still be undefined, right? So we still maintain that property of the 3 being undefined in the original and then in its divided answer there. Okay, questions on any of that? Okay. Jenna, were you able to get the final answer at least then? Yes?
I couldn't catch up, but I'm sure I'd be able to.
You'd be able to. Okay, well, that's okay. All right. I'll try and go slower for this next one here. Well, actually, I'm going to let you guys do this one so you can go at your own pace. All right, but I'll help you get started with this. So, next one, last one here, and then we'll get into synthetic division. Again, we'll just say divide for our directions here. X to the fourth plus 3x to the third minus 10x squared plus 15x minus 10 all over x squared plus 4x minus 6. So this one's a little bit different, right? We're not dividing by a binomial anymore. We're dividing by a trinomial or a quadratic. So we'll put the same setup here. Keep an eye out for any placeholders, but it looks like we don't need any placeholders here. Okay, like so. That's our setup there. And so from here, same question. Even though we have 3 terms, you still want to use the lead term to guide you, so the x squared, and then you're just going to match it up to, you know, our other pieces here. So we want to know, you know, how many, or what times x squared gives you x to the 4th. So what would that be? What times x squared gives you x to the 4th? X squared, right? 1x squared. So x squared times x squared, x to the 4th. X squared times 4x, 4x cubed. X squared times minus 6x, or minus 6, minus 6x squared. Okay?
Is the coefficient on the first term on the bottom, is that x to the x cubed or x to the second or to the 4th?
That's a 4, that's a 3, that's a 2, that's a 4, that's a 3, that's a 2, that's a 2 right there.
So you're putting the lead coefficient multiplied by the 1x
Mhm.
to the 4th, or 1x. Oh, I see.
Yeah, 1x squared times 1x squared gives you 1x to the 4th.
I see.
Mm-hmm. Yep. Okay. And then, again, we'll subtract that quantity. But instead of subtracting, I'm going to make it add the opposites. And then, of course, our variable lead term cancels. And then we have some other stuff here. Negative 1x to the 3rd, negative 4x squared, and then we'll bring down that plus 15x. Okay? And then just go from there. You guys go ahead. Take it away. Take it away. Okay? Dot, dot, dot.
Okay, I can do this.
Give this a try here.
And I have no pencil.
Uh-oh. Let's see. Do I have a pencil?
I do, however, have a spoon.
A spoon? Well, I don't know if I've... Let's see. I do have a pencil. I found this one on the ground outside. But it's mechanical, and it still has some lead. It's just a little banged up. Put a zero if you want, but you can also just cancel it too. It's your choice. Okay, good. Yeah, that should be good. Yes, good with me. Thanks. Oh, great. Thanks. Looks like you guys in the back row here. You can see this. Yes, we got it. You got it?
Yeah, we got it.
Oh, I see. Okay, I see where you. Okay, I see where. Okay.
Oh, did I write the wrong spot?
Yeah, but it's okay. That's all right. No, it's okay. That's all right. I see it now. So, I mean, I'll be able to tell. It's not a big deal. So, but you do get a 0 for correct scoring today. So, okay. Yeah, that's the right remainder. Yeah, looking good.
I think it's because this should be, that's right, and that's right, but I think there should be a negative 6 instead of a positive 6 there when you do your math. Because it's negative times a negative, so it becomes positive 6, but then when you're subtracting, so it will be a minus. So it'll be 15 minus 6 to get your answer there. So yeah, good. Yes, Ron. So looking. Yeah. Yeah, not looking good.
So we just pull down the next 2 terms after that?
Yep. Next 2 terms, if you need to, yeah. Or just next term, depends on what you've got. Okay, so there's your answer, folks. Okay, with the remainder of 9x minus 10. Okay. So Do these evenly divide? No.
I'm confused.
Sadly not. Okay? Question, Jeff?
So, if we pull down the next two terms, wouldn't they just cancel?
So in the next, in the last kind of step here, the negative 1x cubed,
Just the second step.
from here you're saying?
Yeah.
So, right, you don't want to bring down, you just want to bring down one more, I guess. Just bring down the 15x, that's it.
No.
So you have three terms there.
So do we see how many times 2x or x squared plus 4x minus 6 goes into the x to the fourth?
You use the lead term, x squared. And ask yourself the question, right? Ask how many times is x squared, or what times x squared gives you x to the fourth? That's probably the better way to go. What times x squared gives you x squared?
Step.
And then you do the same, you distribute it. X squared times that, x squared times that, x squared times that, and you write them all out.
Oh, I see.
Because it distributes. It distributes.
Distributes to the x.
The whole thing you're dividing by there. Distributes. And then you bring it down. Okay? And keep doing that
Okay.
to continue the algorithm. Okay.
Yeah.
We got to get into synthetic division, though, here, so let's do that. Okay. Synthetic division is a shortcut for dividing polynomials. It's got strengths because it kind of like cuts out a lot of the fat, but it also is limiting in that you can't use it for all of the division that you can with synthetic division. Okay? So you can only really use it for dividing by ax plus b. Okay? So in other words, if you're trying to divide by a quadratic, can you use synthetic division? No. Not unless the quadratic factors, and then you can divide by each of the individual factors, but you can't divide by an entire quadratic. Okay? So let's see an example here. So again, let's say simplify f of x equals 6x to the third minus 19x squared plus 16x minus 4 all over x minus 2. So yeah, simplify f of x equals 6x to the third minus 19x squared plus 16x minus 4. Okay, all over x minus 2. This is exactly the one that we did in the notes, right, earlier for long division. But this is a way we can also see that it works for our synthetic division as well. Okay, so the setup for the synthetic division, and different teachers write this like in a slightly different format, but we're going to start by drawing a little box right there. Okay, and in that box, we're going to put the zero of what we're dividing by. Okay, so in here is the 0 of x minus 2. Okay, so what's the 0 of that? Well, it's 2, right? 2 makes that 0. Okay? Then across that, and on that same line, we're going to put the coefficients of the thing we're dividing by. So 6, negative 19, 16, negative 4, right? Keeping those signs. We're going to leave a line empty and put a little bar there because we're going to be filling in numbers here. Okay? So this is the coefficients of this. Okay? Include placeholders. Right? Include placeholders if necessary. Okay? As part of the problem with this too is that we get it's such a fast method, and you just whoop, can write it down so quick that you can real easily gloss over the placeholders. All right. And then we start this whole thing off by dropping down the 6 right down here. Okay. And then we take that 6 and we multiply with the 2. So 6 times 2 is 12, and then that goes right here. Okay, and then we add. Okay, and we get negative 7. Okay, and then we repeat. Negative 7, times the 2, negative 14. Negative 14 and 16, 2. 2 times 2, 4. Negative 4 and 4, 0. Okay. These numbers that we get at the end, these are the coefficients of the solution reduced by 1 degree.
Excuse me?
Yes.
So I'm a little behind. Can we go back and I want to see the answer to the
long division problem?
Yeah, the long division problem that we had to do ourselves is you get stuck. Let's see if I know there's no solution, but let's see if I got stuck in the right place.
Okay. So yeah, C. And
EX.
I'm going to keep going with this, but I can answer your question later, okay? So look through that. You can look at the notes, though, if you want to there. All right.
What? 9x minus 10.
That's your final remainder, yeah. Okay, so
How did I get it wrong?
I'll come take a look at it in a little bit, but I got to do the long
I
division
see.
effectively.
I see.
Okay, good. All right, so anyway, yes, there it is. Okay, so what do I mean by reduced by 1 degree? Well, what's the degree of the original problem here? It's 3, right? It's the highest power. So the highest power for our answer is going to be 2, right? So it'll be 6x squared minus 7x plus 2, and then remainder is 0, right? So this last number is the remainder, which is 0, which is good. That means, again, it divides evenly, which, again, we know that to be true already, but no surprises there. Okay? So, let's see here. I think in the interest of time, are we ready to try one on our own?
Yeah.
All right, let's try it out here. So, simplify 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18 divided by x minus 2. Okay? I'll leave that up so you kind of see that part. Once you do that, then divide your answer by x plus 3. Then factor that answer. Okay. So you really have 2 divisions, and then I want you to factor your final answer. That is not the spirit. I'll come and help you, Jeff, in just a second. Let me get this written down. Let's see here, Jeff. You might need some motivation. Let me see if I've got my motivational poster. I haven't put it up yet, but take a look at that. There you go. Okay, so don't forget that, all right, Jeff? It's called a trash can, not a trash cannot, okay? So anyway, do you have a question about the long division? Or is it the synthetic division? Okay. So
I was working very hard on the previous.
I got you.
Because I was behind.
all right, let me show you. So we're redoing the earlier long division problem that we did.
Yeah.
Okay, you take the thing you're dividing by, the x minus 2, you get the 0. So the 0 is positive 2. Put it in a little box there. Then you take the coefficients of what you're dividing and put those out on your line. So far, so good? And then you drop that 6 down to start. And then the 6 multiplies with the 2 to make 12. So you put the 12 there. Negative 19 and 12, negative 7, right? Add them up and then repeats. The negative 7 times 2, negative 14, add 2. 2 times 2, 4, negative 4 and 4, 0. And then you're done. Just follow the procedure here. So just follow the algorithm. So drop the 6. 6 times 2 is 12. Add negative 7.
So you're just dropping them down to the bottom and then the middle is your answer?
Nope, these are your final answers that you want.
Oh.
These numbers at the bottom are the coefficients of your solution. Well, all right, so I'll show you this one here. So the same thing, okay? So 2, 7, negative 4, negative 27, negative 18, there they are. We're dividing by x minus 2, so I made it a positive 2 here. I dropped that 2, this 2 goes down, and I did 2 times 2, 4. 7 plus 4 is 11.
Okay. I got it.
11 times 2. Adam,
Where your pen was pointing was confusing me.
okay, you're okay now?
Yeah.
Okay.
So let's try it.
All right, you try it.
X plus 1 plus 20x minus 10x squared. Minus plus 15x minus okay. Okay.
Question. Yes, go ahead, IG.
So we got divided by so why is there 4 terms on both? Shouldn't there be 3 terms on one and 5 terms on the other?
What are you talking about?
If you're just putting the coefficients.
Yes. We start with the coefficients of the original one, but then I wanted to take your answer from the original division and then divide that further by then the x plus 3. So you had 5
Oh, wait.
coefficients from
Oh,
the
I see.
original
It's
one,
not
but
the
then
it's not the trinomial one. It's the binomial one.
yes, you can only divide using synthetic division. You can only divide by binomials.
Well, that's my problem.
Yep.
What was the binomial one again?
I'm not sure. Like an earlier problem, you mean?
Yeah.
Here. There's one right there. Okay.
X.
So there's our final answer. So you can see, right, hopefully now how we can use synthetic division and long division to help us factor, okay? We were able to take a polynomial here that otherwise, is there a GCF for this polynomial? No. Could we group this? Not really. It's an odd number of terms, right? Could we use substitution? Not really. It's not really in a quadratic form. So if we had seen this, yesterday or whatever, we would be stuck. All of our strategies that we have available to us would be useless, okay? But now at least we can divide this. We can break it down into its factors. What's the one catch, though, with synthetic division and long division? Okay, so with synthetic division, it's got to be linear, right? And if it's not linear, then we can at least go to long division, right, and use that. But the other thing is, we were told what the factors were, right? And so we were given that. Oh, these mod? Yes. Okay. For my students. Yes. No, I do. Thank you. So. I know. I'm sorry, Mr. Mills. I'll write them up for bullying. Yeah. All right. So anyway, so there it is. Okay. So that's how you factor those polynomials. Okay. But
So
again, the
the,
problem is you have to know what the factors in the first place.
So all of the 5 terms are 1, negative 10, 0 because there's no.
Right. You put a placeholder in.
Yep.
Okay. So your
Other
homework.
way around. That's